Hi guys, so now I'm going to do the applications of differentiation of trig. I'm going to do the worked examples, there's 2 of them, and then I'm also going to do question 8 from the text because a lot of people get this wrong and get a bit stuck. So in the first example, there's a triangle and it's in the circle there, so you can see that triangle PQO. And what we're being asked to do is show that the area of the triangle is half cos theta. So let's worry about that first. And we know that area of a triangle is half times base times height. Now the base, well, that's pretty easy because that would be the base of your triangle. And the height, well, the height of the triangle would be this line here. And we know that they are the height and base because they are at right angles from each other. So we can see that the base is 1, so half times 1, but the height might be a little bit more tricky because, well, you don't have a value there. What we can do though is we can use this triangle and we can see that that green line is the same as if it was on the bottom. And this is a right angle triangle, and well, we know that this is the cos value. So this is cos of theta because it's the bottom of the triangle, the base of the triangle. So actually we've already done it. So area, therefore area equals half cos theta, QED, as required, as shown, one of those sort of sayings. So we found the area function. Now they're asking us to find the derivative when theta is pi on 6. So if we're trying to find the derivative when it's pi on 6, we're going to need the derivative. So dA over d theta is going to be, well, let's think about cos like we did in the last video. Cos looks like this. And of course, that means that you're going down the hill, so it's negative sine. So there's nothing to differentiate here. The derivative of theta would just be 1. So we're going to have negative half sine theta, and then, well, now we can just sub in the value. So when theta is pi on 6, dA over d theta is going to be neg half sine of pi on 6, and everyone knows that sine of pi on 6 is half, so it's neg half times half. So dA over d theta when it's pi on 6, well, it's going to be negative 1/4. So that would be our answer. So not too bad, but you'll find in this exercise there are quite a lot where they want you to prove something, and they're a little bit hard, hence why I'm going to do question 8 in this video. All right, the next one a bit different. They've got a function to model the temperature on a particular day. T is the time after 5 a.m. So make sure you're really aware of that. Calculate the temperature at 8 a.m. So 8 a.m, that's 3 hours after 5 a.m. So it must be that we're just doing T of 3. And that's going to be neg 3 cos pi on 3 plus 18. Cos of pi on 3, we'll do that first, of course. Cos of pi on 3 is half. Negative 3 times half, neg 1.5 plus 18, and we're going to get T of 3 is 16.5 degrees Celsius. So 16.5 degrees Celsius at 8 a.m. And that's probably the best way to answer it because it is a worded problem. At what times of the day is the temperature 20 degrees? Okay, so we're just equating to 20, so let's do that. So neg neg 3 cos pi t on 9 plus 18 equals, was it 20 degrees? So we're going to get cos pi t on 9, 20 minus 18 is negative 2, 2 on 3. And, well, this is a value that's not in the table of exact values, so it tells you that you're absolutely using CAS here. So if we solve on CAS and we would use the domain, we're going to get T equals 6.6 and t equals 11.4. And you cannot leave it like that. It's asking you at what times of the day to the nearest minute is the temperature 20 degrees. 6.6 and 11.4 mean nothing. So remember how 0 represents 5 a.m. So this is 6.6 hours after 5 a.m. So 5 plus 6 is 11, so it's 11 something a.m. The tricky bit is working out what the 0.6 is. Well, not even tricky, but just something that people don't do so well. So we're going to times that by 60, and we're going to get 36. So it's 11:36 a.m. We do the same thing with 11.4. It's 11.4 hours after 5 a.m. So 11 a.m. and then 5 a.m. Adding on 11 hours, it's obviously going to go to p.m. and that's 4 something p.m. 0.4 times 60 and we're going to get 24. So these are our times. So just make sure when you've got a question like that, you look at the domain and you also know that you answer it appropriately. So not, 6.6 and 11.4, that's inappropriate. All right, find dt over dt. Well, that's not too bad. Oh, I better write the actual function there. Neg 3 cos pi t on 9 plus 18. Okay, so let's do now dt on dt, which actually really I would probably call it t dash of t because it's in this form. But look, they've asked us to do it like that, so I will. So remember, we're going to take the derivative of pi on 9t, which is just going to be pi on 9, and we're going to multiply that by, well, we've got cos here, and this is a negative cos graph. So a positive cos graph is this. A negative cos graph is going the other way. So it's going to be going to positive sine. We're walking up the hill. So we're going to multiply that by positive sine pi t on 9. And of course, the 18, well, the derivative of 18 is just, will go. So that means we've got dt on dt is going to be pi t on 9 times, and hold on, I think I just got rid of the negative 3. So I missed that negative 3 somehow. So it's, so hold on, we got the 3, so it's times 3. And then sine, oh dear, I'm just going to go back. Take 2. So I've left out that negative 3, so I'm going to leave the negative 3 there. Now I'm taking the derivative of this, which is just pi on 9. Fine, and now I'm going to multiply that. If I've already dealt with the negative 3 here, well then the cos is going to turn into negative sine. Okay, that's better. So now the two negatives will cancel as we expected. 3 times pi on 9 is pi on 3. Sine pi t on 9. So just be careful. As you saw, I stuffed that up because I acted as if it was a negative 1. It's not, it's a negative 3. So I needed to consider that as well. Can't just get rid of it. So now that's dt on dt. And now they want the rate of change of temperature at the times found in part B. So the times found in part B, we had those decimals 6.6 and 11.4, and that's what we would sub in. So if we've got at 6.6, and you would just do this on CAS, we're going to get dt over dt equals pi on, actually just sub it into CAS, so we're getting 0.78. And to answer that properly, we can say, well, this is a positive, so it increases by at a rate of 0.78 degrees Celsius per hour. For when it's 11.4, dt over dt is going to be negative 0.78. So we can say, well, it's negative, so it decreases at 0.78 degrees Celsius per hour. So make sure you put your units in and that you answer in an appropriate way. All right, let's move forward, and the last thing I'm going to do on this video is this question here. I don't think it's the hardest question in the exercise, but it's just one that a lot of people get stuck on, so I think it is good to do. So here we have a circular running track. So the circular running track is this thing, and then, well, the centre is the O there, that's pretty obvious, and then they show us the radius being 200. So what I would do when I start a question like that, I would add in information that's not there already. So for example, I'm going to put a 200 here because that's the radius as well. So any radius of the circle is going to be 200. I wouldn't put that one in, but anywhere I had that line, I would put it in. This triangle, it has two sides the same. So it means that these two angles are also going to be the same. Now notice that 2 pi equals 360 degrees, pi equals 180 degrees, and pi on 2 is 90 degrees. So this triangle, this whole triangle here, this is going to be a right angled triangle by the virtue of the fact that it just is within the circle there. So this is a right angled here, angle in there. And we can see then, well, we're dealing with theta and we're dealing in radians. So if we're looking at 90 degrees being pi on 2, if we subtract theta, well, that's what this is going to be. So I'll try and put that in. So pi on 2 minus theta is in there. Now, furthermore, this is also a triangle with two sides the same length. So that means that here must be pi on 2 minus theta as well. And look, we can add the other ones in. If the whole thing, the whole triangle being 180 degrees is pi, so, well, in that case, we're going to be, well, 180 degrees being pi minus 2 theta. So we would have that in there. Furthermore, then, well, we have this triangle, we can say, well, this bit of the triangle here, this angle here, is going to be either, we can say, well, here's 180 degrees minus pi on pi minus 2 theta, or you could say, 180 degrees minus these two, and of course 180 degrees is pi. So I'm going to say 180, which is pi, minus pi minus 2 theta. So I'm subtracting this part of it from 180 degrees or pi, and I'm going to get positive 2 theta. So it goes in there. So look, it's a little bit messy there, but hopefully you can see how I've labelled that all in. Not all of them need to be there, but I've put them all so that we can see any information we need will be there. We'll have it. So let's have a look. If M and P angle, or M and P, so M and P, so just, oops, there we go. This here, this angle in here is theta radians, and the total time to complete the course is t seconds. Show that t is this. So we're dealing with time, and we know that speed or velocity is distance over time, and therefore t is going to be distance over speed. So we need an equation that has the distance over the speeds. They have given us speeds 2 meters per second and 5 meters per second, and it's saying that they do an obstacle course from N to P. So that means we're going along that line there. So let's have a look at that first. I'm going to just take it over here, and I'm just going to redraw the triangle. And this is our right angle. Here's theta. And then remember that the middle of the circle, is somewhere there in the middle, and it's 200 on each side. So this is 400 altogether. So then, well, we're trying to find this distance here. there. So we're saying this, we need the time taken to complete the distance Pn. So I'm going to label P and N in there. Well, let's work that out. We can just use SOHCAHTOA, O, H, and A. We need this. This is the distance. And then, well, we've got this. So it must be cos theta equals distance over 400. So that means that our distance is 400 cos theta. And we don't know what theta is, but that's a variable. So don't worry about that. We have the distance, 400 cos theta. And we know that our time is going to be the distance over the speed. And the question tells us the speed. It tells us 2 meters per second. So divided by 2, and that's going to be 200 cos theta. So far, we've got the time that it takes to complete the run. So obstacle course, an athlete at a morning training session completes the obstacle course from N to P at a rate of 2 meters per second. So it doesn't say it's running, but I'm guessing they're running. So I'm going to say T equals, so we had 200 cos theta. So we've done the first bit. Now we have to do the series of hurdles from P to M along the running track. And that's the bit that people get a bit stuck on. They don't realise that along the running track means you're actually doing this. So it's not the straight line. So it's that arc of the circle. Now let's take that out, and we're trying to work out this distance here, the distance of the track that you're doing the circle on. And we can see that the centre of the circle, the section is 2 theta. So you might remember back in probably year 8 when you did a section of a circle, if that was theta, the formula for that, the formula for a whole circumference is 2 pi r. So to find the sector would have been the angle over 360 times 2 pi r. Well, now we're not dealing with 360, we're dealing with 2 pi because we're looking at radians. Furthermore, we know that this value here, this angle is, let's go back and look, 2 theta. And we know the radius of that as well. So let's go back and have a look. So the radius is this, the 200. So we can put that for 200. So we get this distance is 2 theta over 2 pi times 2 pi times 200 over 1. So, well, they will cancel out for a start. And it equals 2 theta times 200. And that is 400 theta. So that's our distance. And remember, we are looking for the time. And the time is the distance over speed, which is 400 theta over, and I'm pretty sure it was 5 seconds per meter. So that will give us 80 theta. So our time is 80 theta. So let's go and add that to the total. And it doesn't look exactly the same, but I think if I take out a 40, yes indeed, 40 times 5 is 200. 5 cos theta plus 40 times 2 is 80. So there we go. Therefore, T equals that as shown, as required, QED, one of those things. So that's part A. So now it says find the value of theta when dt over d theta equals 0. And notice that that's a special point when you have the gradient equals 0. It would be a maximum or a minimum, a turning point. So this is like a light bulb one to think, okay, well, what is it when the gradient equals 0? Oh, it's a turning point, or it's a maximum or a minimum. Okay, so dt over d theta. Well, 40, that can stay the same. The 5 cos theta, that's 5 times negative sine theta, plus, well, that's going to be 2. So notice that we differentiated the same as if it was an x. So that's pretty straightforward. That's our derivative. And we want to find when that equals 0. So let's see, divide by 40 still equals 0. So we're going to get sine theta equals -2 over -5, which is 2/5. And look, you're going to find that on CAS. Notice that we have a domain there, so we would definitely be putting that in, otherwise we're going to get a general solution. And we end up with theta equals 0.4115. Now notice that that's the value of theta for when the gradient is 0. Now they tell us to make to work out the maximum time to complete the whole course. So that maximum time occurs when the gradient is 0, and we've just found when the gradient is 0, theta equals this. So that means the time taken, we just need to sub this back in to the formula that we proved earlier on. And remember, even if you couldn't prove the formula, you would still be able to do other parts of the question, such as this, where you can differentiate that and then, sub it in, so you can get at least some marks. Okay, so putting that into CAS, I'm getting 216.2244 seconds. And it says to us, let's have a look, in minutes and seconds. Okay, so minutes, we can divide that by 60, and we're getting 3 minutes. And then we can times this by 60, and we're getting 36 seconds. And that completes question 8.